Hi, everybody, and welcome to the Automation Village. This is our August edition of our virtual trade show for people in the SCADA and automation industry. I'm Dave Spencer.
I'm Chris Little, and over the next hour, we are going to, as we always do, bring you experts from the automation industry across the world. Some of it's going to be new material. Some of it will be greatest hits.
Right, and while you're watching us in our summer format again, where it's a pre-recorded show, we're still going to give you a lot of the live experience that we bring in the previous Automation Village shows. So we've got our live chat going, so you'll be able to go in and talk to some of our experts in the box on the side. We're also continuing on with some of the contests that we've been doing. So Chris, did you want to talk about that a bit?
Yeah, Dave. So basically, anyone who doesn't have a conflict of interest can enter into our contest for some significant prizes. So for example, Dave and I cannot, our loved ones and family members cannot, our coworkers cannot, and also any of the presenters you see today or any of their loved ones or coworkers also cannot. But if you don't fall into any of those categories, open up your email right now and put natasha.lutz@trihedral.com and get ready for the code word.
Right, and we're going to give those twice throughout the show. And if you want, you're seeing probably the bulk of the contest rules on the screen right now. But if you want to check out the full rules, you can see those down in the description below.
Absolutely. So first up, let's get started with a big announcement. We'd like to announce our third VTScada distributor, which is CB Automation out of Toronto, Ontario. And they'll be the new distributor for the province of Ontario. Now, over the last 5 years or so, we've experienced an extraordinary amount of growth. We've opened up new offices across the world. We've hired new people, and we find again and again that when we have boots on the ground, we have success, just like in the city of Houston, right?
That's right, yeah. And we've had BTSM working out of Western Canada for a long time now. They've had a great success. We've had a really good relationship with them, and the distributor model has worked really well. And like I say, it's tried and true in Canada. So it should be pretty smooth sailing going into Ontario, and we see a lot of opportunities there that we are not able to capitalize on. So now we think it's going to be really great to see a little bit more VTScada in Eastern Canada.
Yes, and Ontario is a market that's really open for change right now. That's what I hear from a lot of people. So coming up next, we're going to talk to CB Automation's Vice President, Larry McLean, and he's going to tell us who they are and what their plans are for the future.
Great, let's go to that video now.
Hi, Larry. Thanks for joining us today. How are you?
I'm fine, Chris. How are you?
I'm great. So we're really excited to be working with you as a distributor. Can you tell us really briefly about CB Automation and what you do in the Ontario market?
Okay, CB Automation is over 35 years old, and in the Ontario market, we sell SCADA, obviously, and process instrumentation. And we provide products for flow, temperature, pressure, the usual gamut of instrumentation products. But we also provide service and training on all of the products that we sell. And so our marketplace is municipal, petrochem, chemical, of course. We're into nuclear, pharmaceutical, and in some cases we're into transportation.
That's great. So obviously we didn't make this decision, either CB Automation or VTScada. We didn't make this decision overnight. Tell us a little bit about the process, how you arrived at the decision to rep VTScada software.
That's an interesting question. It started out with actually a meeting with you and our president, Nazim Ismail, at a trade show. And he came back all excited. You know, our history goes back many, many years with SCADA systems. And so he came back and said, you gotta see this company. And anyway, conversations, I guess, went on for a while. And then you people were kind enough to invite us to Bedford in February. And we had the opportunity to meet with the principals of the company and be introduced to the product. And it was pretty exciting. And we came back pretty pumped that this is a company that we would feel very comfortable to be involved with and to support.
That's great. We felt the same way. I mean, we're roughly the same age as a company. We have a very similar corporate philosophy when it comes to support and working with customers and integrators. So tell us about the next few months. What are your plans in terms of moving VTScada even further into the Ontario market?
Well, the next few months are going to be hectic. Well, first of all, meeting all the integrators and introducing them to the product. most of them would know it, but some may not. Certainly focusing on the end users where our strength has been in the past. Making sure that the systems integrators know we're here to support them by way of training, in fact, supporting them for the sale in that case. We're going to be setting up webinars and seminars and working with media like Zoom and whatever other people are comfortable with. The market's changed now. The pandemic has changed the dynamics of doing business. But being able to do the presentations and then in support of your product to, like I said earlier, to the systems integrators, to support them in their efforts is really what our focus is going to be.
That's great. Well, thanks so much for joining us today. We're looking forward to what happens in the next few years.
Thank you, Chris.
Have a great day.
Thank you.
Chris, that was a really great interview, and it's nice to see how enthusiastic CB Automation is to be joining the VTScada team and to be a VTScada distributor.
Yeah, I really enjoyed speaking with Larry. Glad he could join us. They've got a lot of history in this industry. They've been a part of this market for decades now. So I think it's a really great combination of VTScada and CB Automation.
Right, and going into this, you talked a lot about boots on the ground and the importance of having boots on the ground and how influential that's been in our sales cycle. And where we are today in Boston, Massachusetts, this is actually a relatively new place for us to have boots on the ground as well, isn't it?
Yeah, it's true. Tim Donaldson joined us a few years ago, and he's already been making a difference in this market. And again, it makes a difference that he's from here. He's already built those relationships. And again, when we can show up in a room and actually have a live person demonstrating the software, it always makes a difference.
Yeah, it comes back to that video that Pete did that says check marks are not always equal.
That's true. You should watch that again. So, which leads us to Tim Donaldson, our person in Boston, Massachusetts, is now going to take us on a guided tour of the city he loves.
Right. So thanks very much for this, Tim. And after this, everybody will feel like a local.
Welcome to New England in the summer. The Automation Village picked my favorite time of the year to visit Massachusetts, the state that I live in. I want to take a few minutes today to tell you some of the fun things to do in New England during the summer months. Let's go. From Cape Cod and the islands to Newport, Rhode Island, and the lakes of New Hampshire, there's an adventure awaiting. While visiting Cape Cod, you need to hit the beaches, take a day trip by ferry to Martha's Vineyard or Nantucket. Once you're back from the islands, you can visit the New Bedford Whaling Museum or enjoy some great New Bedford scallops, delivered daily to the docks. Continuing along the south coast, you can visit Newport, Rhode Island, my favorite summer hangout. While in Newport, you can take a tour of the mansions on Bellevue Avenue, a stroll on the Cliff Walk, fly a kite at Breton Park, or go sailing out of Newport Harbor. Heading north, you can take in all the history Boston has to offer. Visit several coastal towns on the North Shore before taking a dip in the lakes of New Hampshire. Let's not forget, when you come to New England, you cannot leave before picking up some things from my favorite football pro shop. And when in Boston, we don't pronounce our R's. The traffic circle is a rotary, a water fountain is a bubbler, and those sprinkles on an ice cream cone, they're called jimmies. And before you leave, remember to park the car by the harbor and get a lobster. Enjoy the trade show. Thanks for visiting New England.
Thanks, Tim. That's great. So now it is time for a contest.
Contest time.
So,
So, Chris, if you were not you and I were not me, then what would you be putting in your email right now?
You would be putting in the phrase that you could see on the screen right now, which is scalable, SCADA, software, all uppercase, only 2 spaces between the words, because it will be machine read, so humans aren't going to be interpreting this, so get it exactly right, and then hit send.
Right. And you're going to send that to?
natasha.lutz@trihedral.com.
Right. So get that in now, and you could win a $100 gift card to the online shopping vendor that you could probably guess who it is, but we're not supposed to say.
Whose name rhymes with Blamadon.
Yes.
Get that out. So again, the phrase is scalable SCADA software. And there's a reason why we wanted to talk about that right now. Tell us a little bit about scalability, Dave.
Yeah, it's one thing that we run into a lot is people talk about application architecture, and they talk about application size and application growth. The number of I/O that we get is growing. People want redundancy, they want security, they want a reliable system, and they want a system that meets their needs and doesn't get bottlenecked anywhere. And when you look at those systems, we often see that when people think about that, they'll say like, can your SCADA server offer 1 million tags? We'd say, well, it can, but when it comes down to laying out that architecture, you're probably going to find that you're going to solve that problem by having a number of servers, and those servers you're going to find are becoming distributed in a way that is not just optimized for the server, but it's optimized for your network architecture, and it's optimized for your failover scheme, so that when things fail over, they fail over in a logical way, so that not everything goes back necessarily to one single node, but perhaps that they fail over into somewhere where the network architecture and everything else is also optimized.
So basically, you're distributing responsibility across the system, making good use of making good use of all the different servers, so that one server might be the primary for one thing and the backup for another, and vice versa.
Yeah, and we see this in large systems. It becomes very obvious because it becomes kind of a necessity to make these large systems work as efficiently as the end users would like them to. But even in small systems, we're starting to see this where people want to have a few of their lift stations running a VTScada server or something, and then that's going back to a different server and a different server, and they may have things failing over even at the smaller level inside their 900 megahertz network or something else before that all goes back to their bigger network at maybe their wastewater plant or whatever it is. Right. So it's kind of neat. And one of the things that really makes that work is that not having that limit of VTScada of one sort of primary and one backup. That idea of synchronization and unlimited backups really gives you that flexibility to make that system work the way that you'd expect it to. And it's a really subtle difference. It's something that's really hard to get across, especially in a spec sheet or something, but it's something that can make all the difference in these larger applications, and also makes it so that you can take your application today and grow it into the application of tomorrow.
So just to take one step back, if you did have just two servers, a primary and a secondary, VTScada makes that very simple. There's very little configuration you need to do to make those two servers completely synchronized with each other. You don't need to have like a whole other methodology to back up your historian. VTScada is an historian, and so all that happens automatically. But like you said, Dave, you could also spread that out across multiple servers and actually distribute that responsibility rather than just having a complete copy here, a complete copy there, which you can totally do, but you can be more sophisticated in how you share the load.
Yeah, and you can even have it so that the servers jump in and out of synchronization. So we've seen an application in oil and gas where connection between devices was intermittent, and they would say that basically if the connection is possible, everything will sync, and if it's not possible, then one of the devices carries information until they can sync. And I found out recently that this is actually a lot of what happens with F1 cars. F1 cars run on multiple networks. So they have one very low speed network that feeds data to the pits when the car is running on the track.
Right.
But as soon as that car comes into the pit, it actually switches into a higher speed network that they're able to pull a lot of data. So they do like a full data set synchronization in 2 seconds that the car's in the pit. So
that's cool.
It's kind of cool that, we natively support something similar like that. And we have customers actually using it in that way. So it was kind of neat. And yeah, you talked about the two servers. And I do want to just say quickly that I had a system integrator the other day who wanted to learn a little bit about setting up redundancy. So he wanted to do it through a video call, so I set it up, and we had about an hour to do our call, and he was pretty shocked within the first sort of 1 or 2 minutes. I had basically said, well, that's it, so we've got the other 58 minutes if you have any other questions.
Yeah, it's true. When you're explaining it, they'll often just sort of give you the polite nods, like, "Oh yeah, you're lying. That's fine. Yeah." But when they really get it and you can show it to them, they just go, "What? Holy what? Oh my!" You can really tell when the penny drops. All right. So next up, we're going to talk to Mark Bowen. He is the vice president of BinLevel, which is a company that has a really innovative approach both to reading tank levels and also making those levels obvious to people at the site who can just look up and see it on the side of the tank, and also making that data available to the SCADA application of your choice. So over to you, Mark.
Thanks very much for having me.
Tell us about BinLevel, what you do and what makes it different.
Okay. Well, BinLevel started about 3 years ago. I had been involved in monitoring of fuel tanks for residential applications for a number of years. And we were contacted by a operations company, a fracking operations company in Texas, looking for a solution to monitor some of their larger tanks. And while the prior product wasn't appropriate, the opportunity seemed real to create something that was specifically tailored for that application, larger industrial tanks, and not only monitor it and provide the information remotely, but also have the ability to display the information to on-site personnel. So that's kind of the start of BinLevel, and so we've created a product we're introducing now, and that's where it came from.
That's great. So that's a good opportunity now to jump off and go to your presentation.
All right. So as you can see here, this is our application: is monitoring tanks in remote location. What you can see here is one device that sits up on the tank that displays to the local resources how much material is in the tank. And the material can be liquid, it can be grain, it can be a variety of different things, anything that will reflect an ultrasonic signal. But in this particular case, this is a oil storage tank in Texas. And on top of this tank is an ultrasonic transmitter, which pings the material in the tank periodically. Right now it's set to every 5 minutes, but it can do it as quickly as every second if need be, or it can do it every hour, depending on the frequency, and that dictates the battery life of the sensor. And then it's displayed here on this display, this unit you see on the side of the tank, and then that will interface to a SCADA system and provide that information really anywhere that SCADA system happens to decide to transmit it. So what we're all about is basically giving operators visibility into what they have out in the field and trying to make sure that they always know how full these tanks are. In some cases, actually in many cases, these tanks get filled up by the local personnel, and there's a service company that needs to go out and pick up the material in the tanks to be brought off-site to be processed. So it's very important for the people who are in the service company, who are driving these trucks, to be able to know how much material is in these tanks, how much empty space is still available, so the operations on site don't get suspended, and to make sure that they go to the best opportunities to pick up this material. So some of the tenets we put behind the system when we created it is to make sure that we have accurate measurement. That display that you saw on the previous slide gives you 20 segments or 5% increments of what is in the tank, how full the tank is. But through the telemetry and the SCADA information, you can get resolution down to a single millimeter. And while granted, it's unlikely, most people will need that kind of resolution, to have that in certain applications is a big benefit. The prominent visibility, that was exhibited in the previous slide as well. That display is designed to be seen from 1,000 feet away. And it flashes periodically, so it's not on all the time. It flashes every 2 seconds with a high intensity LED on the top and the bottom in red, and then the level is indicated in a green LED someplace in the middle between the top and the bottom. So you can quickly turn and wait no longer than 2 seconds and have a reading of how much is in that particular tank. And you can co-locate as many of these devices on a site as you'd like. There's no limit. So you could have, in this image, we have 3 tanks. You could have 3 of these units, and you could tell how much is in each tank at a glance. The system is designed to be standalone for people who don't currently engage with a SCADA application. So if you just want to have your guys on site know how much material is in these tanks, you can put this up there. The sensor is battery powered. The battery will last a minimum of 5 years. The display can be powered either with a local 12-volt DC source or through a solar battery pack, which BinLevel can also provide, which will basically give it perpetual operation on site. Nobody ever has to look at it again. The system was designed to be simple to install. You might be saying, okay, well, I have tanks that are 10 feet deep. I have tanks that are 30 feet deep. Well, we've designed the system and the display. So with a simple setup procedure, within a couple of minutes, you can set the tank size on the display for whatever depth you happen to be needing to accommodate. So you could have both size tanks, a 5-foot tank next to a 30-foot tank, and both of them would read in 20 segments as a percentage of how much is that 0 to 5 feet or the 0 to 30 feet. And then the integrations, we'll get into that a little bit, but the system was made to be compatible with SCADA systems. It provides a Modbus interface over a twisted pair, so it's good, it's robust, and pretty easy to extract data, and not only measurement data, but also data about the battery in the transmitter, the ultrasonic transmitter, as well as temperature readings from both the transmitter and the display, and other statistics that are typically available in these types of systems. On the how it works on site, this is a image that gives you an idea. So here we have a set of 8 tanks. These are typical tanks used on fracking sites for storing the wastewater that comes out of the ground after it's used. And so what happens is they fill these tanks, and a truck comes and will either drag these trailers away, which they're pretty heavy, or they will actually pump them out into a tank on their truck. So you see depicted on the top of each one of these, this is the ultrasonic sensor. This device is about 6 inches tall. It fits into a 2-inch bung adapter on top of whatever type of tank you want. All it needs on the inside of the tank is a clear shot, cone of visibility down to the material that you're measuring in the tank. So that's the device that wakes up periodically, as I said, every 5 minutes for now, and transmits that information of how far away the level of the material is. And so it measures the ullage, which is the open airspace within the tank, and then transmits that information to the receiver unit, the station, which you see in the picture on the right. So once that station receives that information, it immediately updates. It actually reports the received signal's strength on that RF transmission, which eases installation, and then it displays the latest information for the tank fill. So if your tank were 75% full, you would see these lights flash every 2 seconds, red on the top, red on the bottom, and then a green LED 3/4 of the way to the top of that display. And the distance between the transmitter, the ultrasonic sensor, and the receiver, specified as 500 feet. I've had it go 1,000 feet line of sight, and it depends on the topography. It depends on what materials are on site, but usually it's a pretty good range. So you can actually have the display is quite a distance away from the sensors. Each one of the sensors has a unique ID inside, so you know which tank is being reported, and that gets brought up to your SCADA systems. And every device in the system has its own unique ID, so you know where you're communicating through. You could have 8 sensors with one display because you're only interested in one tank locally, but you're getting all 8 sensors through your SCADA system. So this is your off-site connectivity. So the system will use basically any technology that's available, any SCADA system. The SCADA system usually provides the larger WAN connectivity, but we can also provide this, and we provided the solution over satellite connectivity via cellular or broadband connection to the site. So it really doesn't matter what technology is available, and given the satellite technology today, this can be provided literally anywhere on the planet, not just within the regions from the polar circles, but also globally. There's low Earth orbit satellite. And then for operator visibility, it's a SCADA system, the one that you have or the one that you want, and it provides this visibility on the desktop or mobile devices. And BinLevel has the ability to provide this system if you don't currently have a SCADA system. If you want that connectivity, we have partners that we work with, and we can provide that type of system. So the product itself, it's really comprises 2 components. The ultrasonic remote transmitter, which you see on top, that device is about 6 inches tall. Give you scale, that's a 2-inch bung adapter, NPT, so it's a tapered thread on the bottom. And it will go into the top of any tank. All the requirement is that you want to be within a couple of degrees of perpendicular to the material in the tank to make sure you get a good reflection. But this sensor will operate anywhere from, really, the distance could be as close as 2 feet and up to over 30 feet. It's watertight. It's designed to breathe, so when you get temperature changes, dramatic temperature changes, moisture ingress is not a problem. As I mentioned, it communicates wirelessly, which I think is one of the distinguishing factors of our solution to this other device. So you don't have to run wires up to the top of your tank or across this field to a tank. It's the signal's coming to you, and all you have to do is receive it. So the next item is the station itself. This display, it's 19 inches tall, is readable from a pretty significant distance. It mounts either with magnets, which you see in this particular image, or it can be screwed to the tank. It's pretty light, so it's pretty secure just with magnets. If you have a hurricane or something like that, obviously you may want to secure it better, but the magnets hold pretty well. The sensor pairing. So when you get one of these devices, there's a very simple pairing scheme. Basically, you wave a magnet next to the ultrasonic transmitter. It transmits a half dozen times. At that point, it locks it in. And once it's locked in, that's put in non-volatile memory. It stays that way for the duration. Or you can erase it and pair with another transmitter if you'd like. As I mentioned before, it gives you the received signal strength indication. So you know when you're setting this product up exactly how good your path is between the transmitter and the station. And it gives you the opportunity to adjust. So maybe you move your station up a foot or two, or over to a different, slightly different location so the signal is better. It makes setup a lot easier and lowers the probability that you're going to have signal transmission problems in the future. And then finally, the SCADA interface gives you, you have Modbus. You can interface to so many standard platforms, programmable controllers, other types of things like that operate on SCADA systems. So that's, Chris, that's in a nutshell, that's the BinLevel solution.
Thanks, Mark. That's great. Can you tell us what makes your solution different from others who do the same kinds of thing?
All right. Well, first, I think we're using ultrasonics rather than something like LiDAR or radar, which is a lower cost approach to measuring how much material is in the tank. So our solution, generally speaking, is far less expensive than what the competing solutions were presented a few years ago and indeed now. Secondly is the wireless sensor, the ease of installation, the ability to put the sensor on the tank. If you have a bung adapter on the tank, it takes you the time it takes to walk up there and screw it in. If you don't have a bung adapter, a 2-inch NPT bung is very easy to install on virtually any tank. So the wireless link between the remote transmitter and the station, I think, is a big plus, because you can be up and running in a matter of minutes. Once you've done that, you wave a magnet past that remote transmitter, and it is paired within 30 seconds. It's paired. Now, every time it takes a reading, it's telling you how much material you have in the tank. The battery operation for that sensor, we get 5 years out of it right now, and it could go much longer if need be in the application, but it's user changeable, and it's very simple to change. It's a 2-minute operation to swap the batteries. The simple Modbus interface, we're trying to simplify this. I think a lot of companies might approach this and say, okay, well, I've got an engineer, he's going to get a sensor, he's going to run a wire, or even if it's wireless, he's going to integrate it, figure out the protocol, he's going to do all of these other steps. We want to provide something. You deliver this, you install it, it works. And the connector is a simple 4-pin connector to the station. That's the only connectivity that's required for data. And you get power from that. It's 12 volts DC and provides a Modbus interface, gives you all the information you need to manage that tank or multiple tanks on site.
That's great, Mark. Thanks so much for this. If anyone has any questions, you can reach Mark Bowen at the email address or website listed here. Once again, thanks for joining us. Have a great week.
Thank you. Thanks to you.
Thanks for that, Chris and Mark. That was really nice. So next up, we've grown a lot in the oil and gas industry in the last few years between the work that BinLevel has been doing in Alberta and the work that Blair's been doing in Texas. We've seen a big boom in the number of installs that we've done in oil and gas. Now, we've been in the oil and gas industry for more than 20 years with a surprising number of projects in a variety of platforms, but that was for a very small customer base. So now we're seeing it really kind of explode, and we're honored to have been nominated for this year's Oil and Gas Engineering Product of the Year for the IIoT and Process Control category.
So take a moment right now. We'd really appreciate it. Click on the link in the description in this live stream video and go in there and vote.
We know that our development team has been really pushing hard to meet some of the feature requests and other things that we've had in the oil and gas industry. So it would mean a lot to them and us and everyone involved to win that award.
So while you're voting, just take a moment, everybody right now, click on the link. And while you do that, Dave and I are going to dance for you. So for those of you who attended VTScada Fest this February, which we got right in under the COVID wire, we really couldn't have asked for better. One of our presenters was Ian Schmertzler from Dispel, and he really gave an outstanding presentation. And then he was kind enough to come on to one of our first virtual trade shows after things closed down, and gave us a great presentation.
Let me tell you a story. The scene is a water utility, and what they measure there is what they care about: uptime, availability, and safety. Our protagonists in this tale, that would be our heroes, consist of two characters working at the water utility. The first is an operator, the second is a cybersecurity specialist. They do not like each other. We're going to talk about the operator first. The operator's job is to maximize the uptime, availability, and safety of physical systems. They used to do this very quickly and very well. But how are they valued now? Not based upon how they do their job, but based upon how long everything they have to do to fix those physical systems takes. And thus enters our villain, the intermediate step. Now that used to be, I need to fly out to the job site, or I need to drive out to the job site. These were readily relatable to other people's experiences. But these days, it's mostly, well, I need to remotely access the industrial control system. And that's a problem, because for most people, remote access means just log in. But that is not the case when dealing with a system built with cybersecurity in mind for industrial control systems. Rather, the operator first must VPN to the corporate network. Well, that's an intermediate step. Then they need to go to a jump host on the corporate network. That's another intermediate step. Then they need to go to a jump host on the SCADA cluster. That's another intermediate step. And finally, they need to perform an RDP connection from that jump host down to the asset cluster. That's another intermediate step. Connecting to industrial control systems built by people who care about cybersecurity tends to take between 12 and 15 minutes to go through. Now that is madness. It's negatively impacting uptime, availability, and safety across the water utility, and it's making the operator look slow at their job. This is also wrong because the operator's time should matter. So our hero goes on a journey, and on that journey they find Dispel, a company that does have faults, like letting an engineer write and deliver a presentation unsupervised, but it's very well liked in the water industry by the people who both service water utilities and water utilities themselves. The reason for this is they offer a secure remote access product that connects in under 20 seconds. It deploys in under 4 hours, and it costs, so long as you aren't doing anything crazy, about $25,000 per year, which is between $25,000 and $185,000 cheaper than the system being replaced. So our hero hatches a plan to bring back one of these systems and to prove its success, thus improving uptime, availability, and safety, vanquishing the intermediate steps, and letting our hero be measured by the job they were hired to do, not those intermediate steps. Thus brings us to our intermission, and then Act 2, where we meet our other hero, the cybersecurity specialist. Now they built those intermediate steps, and they did it for a reason. You see, for lack of an alternative option, cybersecurity has long been an exercise in building castles. And as time and money allow, you add additional walls or you improve the ones you already have. This strategy is called static defense, and our hero knows that he needs to use it. When dealing with remote access, most of the world sees remote access as, well, A and B are talking about something, and that traffic stream is what's important. So they say, use a VPN. Between A and B, your job will be done. But when you're dealing with remote access to an industrial control system, the attacker doesn't care about the traffic stream. What they care about is finding A or B to launch an attack directly against those systems. And when you're dealing with a larger industrial control system, it doesn't look like this. It looks like this. So it's very easy to find the target of value. Now, what this means is that whilst our operator thinks they're seeing a bunch of intermediate steps that are getting in the way of them doing their job properly, and thus results in them calling downstairs to the cybersecurity specialist and saying, my time should matter, from the cybersecurity specialist's point of view, those are walls, not intermediate steps. And that's a static defensive structure. The real problem of late for our cybersecurity hero is not the yelling. It's that the cybersecurity structure that he's using isn't working anymore. You see, static defenses fell out of fashion in the physical world because castles do not move. They're easy to find, and unless you are constantly and correctly anticipating the types of attacks that will be launched against you, and then both building those defenses in time and implementing them across your organization, someone will find you, analyze you, work the problem, and punch a hole through. The same is true in cyberspace. So, the static defenses that are out there are beginning to break. Now, there is an answer that our hero knows about. It's been around for about 12 years, and it's called moving target defense. The way moving target defense works, unlike static defense, is instead of putting the thing that you care about into the middle of a big fort, what you do is you put it into a vehicle and move it around, ideally in a medium where it is very difficult to be followed. This strategy, moving target defense, started to be done by hand in the late part of 2008, and since then has expanded to being something of a commercial available product. So our hero prepares for a journey to find one of the commercial offerings of moving target defense, and instead is interrupted by the operator entering on stage right. The operator says, check this out. So my field network's over there on the right, I'm on the left. All I need to do is go to this console, I'm given a workstation with VTScada on it, and bang, I am in the system. Wow, says the cybersecurity specialist, that's very cool. How can that possibly be secure? Enter the network diagram on stage left. Oh, says the cybersecurity specialist, I get it. This isn't just a set of components, this is a system. And these components were built to talk to one another and work with one another without presenting themselves to you. Yeah, says the operator. So, says the cybersecurity specialist, this is segmented, it's recorded, it's temporary, and it's reliable. Yeah, says the operations guy. More fundamentally, says the cybersecurity specialist, this is a commercial implementation of moving target defense. So our heroes band together to deploy this system, which takes under 4 hours, and vanquish the intermediate steps that were driving the operator crazy. The result is that uptime, availability, and safety across the firm improve. Static defense is replaced with moving target defense, and if it's anything like Connecticut Water, our friends see their firm enjoy nearly $1 million in savings in time alone in the first year of use. Time does actually matter, it turns out. And, surprisingly, operations and cyber are finally getting along. The end. Now, why did I tell you that story? Well, did either of those characters sound like you? If yes, try Dispel or book a briefing with us. Thank you.
Great. And now we're going to keep things rolling with another one of our greatest hits. We're going to talk to Scott Coleman from Owl Cyber Defense, and he's going to talk about their unique technology, which is called data diodes.
So we've all gone remote at our company, and we're using remote tools and remote access, etc. And that's a lot about how actual plant operators, etc., are using our products and out in the field today.
Okay, that's great. So what are we going to talk about today?
Yeah, so I think that the fundamental thing we want to get across is really talking about remote access, remote monitoring without remote access. Glenn was just talking about like emailing chain sets and alarms and notifications. Those are all examples of things that can go through what's called the data diode. 20 years ago, we started the company serving the US government. We get the first patent in what's called the data diode. And I'll explain that in a second. And since then, we've actually added about 50 new patents onto that. And about 10 years ago, we took that technology and brought it over to basically the industrial control systems or critical infrastructure part of the marketplace. A data diode, for those that aren't familiar, is a pure cybersecurity device. It is based on hardware, not software, so it's not something that can be configured. We actually let people know that it can't be hacked. Which sounds a little audacious, but I'll explain in a second why we say that. And it's comprised of the core elements really are the LED that's sending light across the diode from the source to the destination, and the photoreceiver on the receiving side that's receiving that data.
That's interesting. It never occurred to me that this actually included an actual diode. I just assumed that was a metaphor. That things could only.
It's funny because there were trade shows, and I know when the guys that get the electrical engineering degrees come up to me because I know what a diode is. So a data diode moves data in one direction. I'm like, yes, you got it exactly right.
Also, there's a diode.
Yep, absolutely. In theory, there's actually two, because there's the send side and the receive side. So the diode acts as the demarcation point between your plant, let's say, and your HQ, where you're going to accumulate information. So maybe in Glenn's example, where the alarm notifications get sent to is one side, and where the sourcing are coming from is the other. So this next slide is really talking about the number of connections you have, because you think about, well, where do diodes get used? And you got to step back a little bit and think about, well, what are those connections and how many of those connections exist? And the average facility has 583 connections. There's a lot of connections that you need to apply cybersecurity resources to, and everyone knows we've got limited resources today. So not to say that a bunch of those 583 aren't valid. We all have reasons why we want to connect our operations to other entities, whether it's to the cloud services, software vendors, disaster recovery solutions, etc. There's a long list there of different reasons and why we need to have external connections and connectivity to our network. And then you have different data types. You have historian connections, obviously SCADA connections, we're talking about today, SIM information, files, syslog, email, etc. All kinds of different data types that need to get from that plant out to end users. And this is kind of what it looks like, right? You've got your plant, your facility in the middle, and you've got all those third parties sort of sitting out there around that plant, trying to exchange information back and forth. And what we want to try and do is control those connections. And so the Department of Homeland Security actually came up with what they refer to as their 7 strategies for defending industrial control systems. And if you break it down, the way to think about it is that 583, you want to reduce that number, right? So you want to get as few as possible so you can then concentrate your cybersecurity resources. And then the next recommendations they make is about converting two-way connections, because we saw those are the two-way arrows between all those entities, and we're going to connect them to one-way out of the plant. And that's really where diode comes in. So the idea with the data diode is, I know because of the physics that you mentioned, the physics is what is the security. The bedrock or the core of the security there is moving data in one direction only. If I don't have components that can move light backwards, then I can't hack the box. And that's really what we talk about being unhackable. Is that idea of I can only move light in one direction, no one can hack through a diode and get back into the plant. And it's all about protecting the plant, your SCADA, historian systems, all the things running on the inside of that plant that are needed and critical for operations.
Right. So in order to hack it, you need some kind of feedback from the unit. I'm putting something in, I want to see what I get out. And if you can't do that, then you can't hack it.
Exactly, right. There's no remote command and control. There's no two-way communications back and forth through a diode. And that's the intent. The intent is, hey, I can only move information in one way. Therefore, there's no zero-day exploit that you can put on there. You've actually got missing components, right? There's no way to physically go back. So there's no software you could load on there that magically will recreate the missing pieces of hardware that are required to go backwards through a diode. You put in a diode, you can be 100% guaranteed that there's no way anybody can get back through the diode into the plant, but you're guaranteed you can get your data out. Yep, that's exactly the point. So some of the people talk about, firewalls where they run on hardware and stuff, but they're not based on hardware, right? They're not based on physics. Software firewalls are based on configuration enforcement, and zero-day exploits, as we know, can still impede them and affect them. You can have people configure things incorrectly, malware, ransomware, all those things can be propagated and work their way through a firewall. And you've got ongoing management where you've got to constantly keep them updated, otherwise they're no longer going to serve the need that the end user is expecting out of them. So with a hardware enforced data diode, and you get the physics, it becomes unhackable, it's invulnerable to your malwares and other things, and there's very little ongoing management.
Great.
Some people say, okay, yeah, okay, great. So some people say, well, that's interesting. The data diode that must be used sort of like in this one thing where you're just moving a file or something. But the truth is, it's big use all of it. We've got a lot of deployments in water, wastewater, power generation, nuclear power plants, renewables, wind and solar. A lot of things going on in transmission and distribution. We've been very strong in oil and gas for probably, that was actually our first foray into critical infrastructure was actually the nuclear plants. As many folks know, that those are all very locked down, one way only. And then from there, actually, there were some threats that occurred in the Middle East. And so we started oil and gas, got into that space subsequently. And then all these other markets, petrochemical, transportation, et cetera, have all started to adapt data diodes. So we're really seeing a lot of activity now. I guess one way you can tell that there's an interest in the market is when you start to see a lot of competitors pop up. And so we started to see a lot of smaller entities creating diodes. And I think that the baseline there is anybody can create for that one-way data diode. It's really about the expertise in being able to connect to the networks on either side. So the diodes is in the middle, that's great. But when you come to the point where you say, you know what, I need to get OPC UA data out, I need to get Modbus data across, I need to do emails, I need to do files, I need to do streaming, I need to replicate historians, all those kinds of things. When it comes down to those things, it's really being able to manage those data types, connect to the networks on either side and get the data in, across, and back out the other side securely and reliably without impeding any of the plant operations.
Okay, just in the last 30 seconds, who's looking for this solution? What end user for this?
Sure. So we actually have 4 personas we target. The OT engineer working in the plant, the IT engineer who needs to get that monitoring information, and then we have partners that we work with like yourselves, and then of course CISO. So it's a variety of folks that are interested in the technology, doing proof of concepts, and really exercising the solution.
Thanks, Scott. And now we're coming up on the end of our broadcast, but we've got a few important things that we still have to do. And the first one being
prize draw.
Prize draw. So hopefully you've got your email still open. And in the to line, please type natasha.lutz@trihedral.com. And then in the subject line, type in
first class support, all caps, just as you see it on the screen.
Great. Now, once you've done that, then please take your mouse and slide it back to YouTube and up into the top right-hand corner and follow VTScada by Trihedral on YouTube. We'd really appreciate that. It makes a big difference to us in terms of the features that we can offer you, and it will also make sure that every single piece of content that comes out goes directly to your inbox.
Yeah, and we're putting out these episodes but once a month, and typically they've got all new content. Like I say, as we've been recycling a little bit in our summer series, but coming back into September with our next episode coming September 24th, we're going to have a whole bunch of new presenters, all kinds of different industry experts to talk about what they do in the industry and how they're helping people make the most out of their systems.
Right. And one of the new pieces of content we're going to do is we're going to have a short, snappy web series hosted by Dave and I called Ask VTScada. So you've no doubt heard us talking a little bit about VTScada through the broadcast. If you have any questions, if you've heard stuff about VTScada, you don't know if it's true, you've got some questions that maybe you think are dumb and you're afraid to ask anyone else, this is the perfect place for dumb questions. Just actually fill them in to the comment section of this or any one of our videos and hashtag it with Ask VTScada, and we'll be sure to include those in our upcoming web series.
Yeah, that's right, Chris. I'm really looking forward to that. This is going to be a much shorter format series where we put out episodes sort of as things move along, and then we'll be answering those questions and just doing very specific VTScada stuff in those.
So that brings us almost to the end, except one more thing. If you'd like to try VTScada for yourself, we offer a free low tag count, 50 IO industrial version of our software called VTScada Lite. It's not a trial, it's not a demo, it is an industrial piece of software that can handle up to 50 IO. You can download it through the link in the very, very long description at the bottom of this email. And also, if you've never used VTScada before, no problem. There's a video on that page that will, in just a few short minutes, take you from 0 to 60.
And we really like to see you guys try that out, see how you like the software, give us your comments, give us your feedback, and we'll hopefully touch on that in upcoming Ask VTScada.
So thanks, everybody. Thanks for your time. Thanks to all of our presenters who gave their time, and we hope you have a great afternoon.
Thanks, everybody. Goodbye.